I'm doing it. Academy, and in this tutorial I'll be taking you through differential equations problems in your preparation towards exams. So we'll be solving a couple of questions and we are going to explain the different concepts and what should do and what not to do with regards to the various questions. So let's move straight to the first question. So this question is preambled: write the degree and order of the differential equation below. So let's see the first differential equation. So the first differential equation we are considering is the squared y over the x squared is equal to the square root of the expression 1 plus the y over the x all cubed. So we have to find the order and the degree of this differential equation. So order in the degree of this differential equation. So order is simply the highest derivative we have. First derivative, the y over the x. Second, the squared y over the x squared. Third, the cube y over the x cube. And in that order to the nth derivative. Okay. So when you talk about the order of a differential equation, you just have to look through all the terms of the equation and select the one with the highest derivative. Okay. And here you can see that in our equation we have the highest derivative to be what? 2, because I can see the squared y over the x squared. When I come here, though it is the power 3, but it is the y over the x. So I will say that my order is what? 2. I've identified my order. Now let's go to the degree. Degree is simply the power to which the order is raised. Once you have identified your order, that is the highest derivative, you ask yourself, what is the highest power is this derivative holding? Sometimes you can see the highest derivative occurring more than 1. In this situation, it's only appearing here. Sometimes you can see another part of the equation still having the squared y over the x squared, but with a different power. So we choose the highest power, and that becomes the degree of the differential equation. So here, please take note, before you find the degree has some few limitations. For you to find the degree of a differential equation, 1, it should always be polynomial. The equation should be polynomial. I mean that it should just be normal polynomial, but it shouldn't have any transcendental function. When we talk about transcendental function, we have logarithm, we have trig, then even this one is a radical. Okay, so you have to always convert your equation from the transcendental, or just convert it whatever it is to a polynomial form before you can find the degree. The degree is simply you finding the highest order the highest power your order is raised. So meaning that your equation shouldn't have radicals. That will bring confusion. So let's solve this by removing the radical and making it polynomial. Okay, to solve that, you square both sides. So the squared y over the x squared all squared. Then I'll have the expression square root of 1 plus the y over the x to the power 3, and this one 2 squared. Okay, once I square, you can see that these two will cancel this, and I'll have the squared y over the x squared all squared is equal to 1 plus the y over the x to the power 3. So now that we have this, let's see what the degree will be. So now what's the highest power to which our order is raised, and that is 2. Okay, So you can clearly see that it's, so the degree is simply equal to 2. Initially it was what, 1, so you may be tempted to write 1. That makes it wrong. So please convert it to polynomial before you choose your degree. Let's go to the second one. So with the second one, I'm going to write my equation here. So question 2, still following the same preamble, I have the expression d squared y over the x squared plus cosine of the expression d squared y over the x squared equals 5x. With this question, what's the order? I come here, this is what? Second derivative. I come here, this is second derivative. Then obviously, my order is what? Second derivative. So order is equal to 2. Now, what is degree? My degree here is simply equal to the power to which, the highest power to which the second derivative is raised. Here, you can see that the second derivative is raised to the power 1. But here, the second derivative is within the argument of a trigonometric function, meaning that we cannot explicitly say that it's to the power 1 to the power 2. We need to simplify this expression to get a polynomial, but that is hell. I mean, we don't have time for that. So anytime you see or encounter this situation, your degree is undefined. Please take notes. Undefined. Every differential equation should have an order, but not every differential equation will have a degree because of transcendental function. Let's look at the third one, which you can relate with that. So with regards to the third one, I have the squared y over the s squared all squared plus 3 multiplying the y over the x all cubed is equal to the expression x log the squared y over the s squared. Looking at this expression that we have here, what is the highest derivative? Here is 2, right? Here is 1, then here is 2. So I'll simply say that order is equal to 2. But what is the degree? To find the degree, make sure that your equation is a polynomial. Is this a polynomial? No. There is a logarithmic function, and it is having the highest power even within the logarithmic argument, right? So because of that, our degree is undefined. Okay, so that is all for order and degree, and I hope I've opened your eyes enough. And we keep on solving the problems. So this is our third question. Okay, so a quick note before we continue. God Academy only started producing videos actively late last year, and already about 20,000 students have watched us, yet we are still under 1,000 subscribers. If you are finding value here, please hit the subscribe button and help us amplify this work. I really appreciate it. So let's go to the fourth question. Okay. So the fourth question, here is another preamble. So determine if the following differential equations is linear or non-linear. Is linear or non-linear. Okay. I have the fourth one to be the squared y over the x squared minus 2y is equal to natural log of x. The fifth one to be the y over the x plus x, I have a y here, is equal to 0. Then my sixth one, I have the y over the x plus y squared is equal to 1. So the question says we should determine if the differential equation we have here, will it be a linear differential equation or a nonlinear differential equation. We can only determine that by analyzing the condition for linearity. In high school, when you talk about a linear equation, it should satisfy y is equal to mx plus c, meaning that the highest power of our independent variable should be what? 1, right? And also, that is, in the high school. But when it comes to differential equation, it's similar. How do you know that the differential equation is linear? It will be linear if there is no expression like y multiplying the y over the x. Okay, so what we say is your dependent variable should not multiply its derivative. It doesn't make it linear. Take notes, it doesn't make it linear. Again, when you have tan or a transcendental function of your dependent variable, if you see tan y, it doesn't make it linear. If you see cos y, so far as you are having the y over the x, the dependent variable should not enter the argument of any transcendental function. If there is log y, it doesn't make it linear. So please take note of the conditions of linearity. Also, the highest power of the y should be what? 1. So if you see y squared, y cubed, you are not linear. You are moving from the linear domain to a different domain. Okay, so with this said, let's see if these equations will either be linear or non-linear. Looking at the first one, the squared y over the x squared minus 2y is equal to ln x. This is perfectly written. It's a second order, higher order. But the fact that it's second order doesn't make it non-linear. Please take note. Minus 2y. Y has the power here, the highest to be what? 1. It satisfies. It's equal to ln x. The natural law we have here is having an argument of x, not y. If here was y, this wouldn't have been linear. So now we can say that this equation here is simply what? Linear. If this should have been y, this whole equation wouldn't be linear. So take note. Let's move to the second one. Y multiplying the y over the x plus x equals 0. Is this linear? The y over the x here is a first derivative, but the y multiplying the y over the x, we will see that if we divide through by y, you end up getting a value of y to the power negative 1 here, meaning that it doesn't make y what? A linear. Therefore, this equation is non-linear. Okay, so this is non-linear. When you come here to, what do you see? You see y squared. Okay, the y squared here makes this equation non-linear. A linear should have the highest power of the dependent variable to be what? 1, and that is that for linear and non-linear. Okay, so let's move to our next question, which is the 6th or the 7th question. Yeah. So question 7. For question 7, I have this equation here for us to solve. T multiplying y prime plus 2y is equal to t squared minus t plus 1. So t multiplying y prime plus 2y is equal to t squared minus t plus 1. Remember, y prime is the same as the y over the x squared. Okay, now first of all, before you solve this differential equation, you ask yourself, what type of differential equation is this? You should know the type of differential equation before you can solve it. So the question that I'm asking is, what type of differential equation is that? So to get the type of differential equation correct, one thing that helps me a lot is identifying the kind of operators. You can see minus, you can see plus, you can see plus. So whenever you see minus, plus, the idea of separable should not come in mind. You can't separate them. So what you should go by is, now I start with linear. So first of all, I don't see y prime very well. So most people prefer t multiplying the y over the x plus 2y is equal to t squared minus t plus 1. I initially in the previous video explained linear and nonlinear, that you shouldn't have dependent multiplying its derivative. Here you can see t is multiplying the over the x, but t is not the dependent here. Okay, t is the extra variables which we have placed them here. So the first thing to do in this problem, so far as that it's not y and it's t, is to make sure that the y over the x is standing there alone. So let's make the over the x stand there alone. We are going to have the y over the x plus 2y over t, right, is equal to t squared over t minus t over t plus 1 over t. Once we've done this, let's write the simplified form. We have the y over the x plus 2 over ty is equal to, on the right side I'll have t squared over t is t minus 1 plus 1 over t. So once I have this expression down here, then I can now analyze and see that this is a linear differential equation. I have my dy over the x, the coefficient of y is 2 over t, then any other thing here is my, q of t, right? So how do we solve a linear differential equation? To solve a linear differential equation, we need what we call the integrating factor. So we need an integrating factor. How do you find the integrating factor? Integrating factor I is simply equal to u. It's simply equal to e to the power integral of what? The coefficient of the y that we have here. Okay. So the standard form for the linear differential equation is dy over the x, okay, plus p of t, depending on, let me make it p of x because we are dealing with x. So let me start that way. So for a standard differential equation which is linear, it follows the form dy over the x plus p of x y is equal to q of x. So meaning that your dy over the x will stand there alone, then there is a term multiplying the y, where the y is to the highest power 1. It should be equal to q of x, which is any other thing, and that is exactly what we see here. So that gives us the go ahead to solve it as a linear differential equation. So what should our integrating factor be? So our integrating factor, as I said, IE is simply equal to e to the power integral of p of x dx. So the coefficient of y becomes our p of x, since you can see from the standard form. So our integrating factor simply becomes e to the power integral of 2 over what? T dt. Now we are doing it with regard to t because it's a t, okay? So here, what you can see here is, sorry, I think I made a mistake here. It shouldn't have been the y over the x. It's supposed to be the y over the t, since we are differentiating with respect to, yeah, that will work. Good. So let me clean all the dx and make it t. So sorry for that error. So here is dt. So here is dt. This is dt. Then this is dt. This is dt. So now we are integrating this with respect to t. Okay, that is how we find the integrating factor. So to find the integrating factor, I have e to the power integral of 2 over t dt. How do I solve this? So this gives me e to the power. If you have this, remember I can push 2 outside the integral. So 2 out, integral of 1 over t dt. And remember that the integral of 1 over t is simply natural log of t, right? So I'm going to get e to the power 2 ln t. T is gone, right? So you have 2 can be the power of what? By logarithmic rule, I can say that I'll have e to the power ln t to the power 2, right? And anytime you have e to the power ln e, then it means that everything here will go away. Then the answer will be the t squared. So my integrating factor IE is simply equal to t squared. Okay. Now that I have my integrating factor, then I proceed to solve my differential equation. So after finding your integrating factor, the next step in solving a linear differential equation is by multiplying your integrating factor throughout. Okay, so this is where we reached. Okay, this is where we reached. So we need to multiply through this equation by our integrating factor. Doing that, I'll start dy over dt times my t squared plus 2 over t multiplying y, then is equal to t minus 1 plus 1 over t, all multiplying what? T squared. Okay, sorry, this one I don't multiply this by t squared. We multiply everything by t squared, everything you have by t squared. Okay, so once you've multiplied through by t squared, then there is this very beautiful rule in linear differential equation which says that whenever you reach this step, you have a derivative of y multiplying the t squared, then you have the y itself multiplying the derivative of the t squared. So this expression, we collapse it to get us y multiplying our t squared. Okay, so this on the left side all the time whenever you are solving linear, please, that's the next step to do. You simply have to take your y and multiply it by your integrating factor and bring a derivative to each. Okay, so this derivative means that it's a product. Okay, having a product rule. So we collapse all this. So when you expand this, you're supposed to get this, right? But just use it as a mathematical rule that whenever you find an integrating factor, attach y to it, all into brackets, a derivative sign, okay, should be equal to, now on our right hand side, let's multiply. T times t squared will be t cubed minus t squared, then this will cancel and get what? 1t plus t, right? So now you have this expression here. What do? We need to find y. The goal of differential equation is to make y the subject, or make y stand alone without any derivative. So what do? I need to find integral to remove this derivative. So integral of the expression y multiplying t squared derivative is equal to integral of the expression t cubed minus t squared plus t. Okay, this derivative cancel the integral, so the expression becomes y multiplying t squared is equal to the integral of t cubed minus t squared plus t dt. So my expression still goes. So y multiplying t squared is equal to the integral of t to the power 3 is what? T to the power 4. So it's going to give me t to the power 4 over 4, right? So it's giving me t to the power 4 over 4 minus, this becomes what? T to the power 3 over 3 plus t squared over 2. Okay, so once you have this here, then you realize that at this point, and whenever you do a different integral, you'll be left with what? C, right? So whenever you do an integral, you should add your, this one is an indefinite integral, okay? So you add your c, that's our constant. So at this point, I said the goal of differential equation is to make y the subject. So y is simply equal to, I'll divide through by t squared. So this gives me t squared over 4 because it will cancel some 2 t's. Minus this one, 2, it will cancel 2, it will be left with t over 3. T over 3. Then plus 1 over 2. Then you have our c. Okay. Please, anytime you do anything to c, or whatever you do to c, so far as that thing is not a function, it remains t. But now since you are dividing through by t squared, c will have here t minus 2. Okay, so we are trying to, if we had removed the c before, then it won't be affected. But now so far as you have c, we are dividing through by what? Our t squared, so it will affect everything. And at this point, since it wasn't an initial value problem, you simply end here, and this is what we call an explicit differential solution. Explicit differential solution is a solution which has y being the subject. Okay, not every differential equation that when you solve you get y to be, you can make y the subject. Some of them you can solve but you can't make y the subject. Okay, and if you can't make the y the subject, we call that implicit solution. So here I've shown you two. We have explicit and we have the implicit. Okay, I know you remember implicit functions, implicit differentials or in differentiation. So explicit is when you can make y is equal to, but implicit is when y will be, should I say, the derivative, right? We are removing the derivative, but we can't make it the subject. So this is what you have for here. Now let's move to our eighth question. Our eighth question. Okay. So our eighth question, I'm going to give so number 8, right? For the eighth question, I have y prime is equal to e to the power negative y multiplying 2x minus 4, y of 5 is equal to 0. So I think you can pause the video and try your hands on, assuming you've seen this question in the midsem and you want to solve, and I mean, you just have to try. Don't just be following, okay? And before also, don't just be following, yeah, please take a pen and your paper and please be solvent. So try and pause it and solve this as if you are in the exams. Can you solve this problem? Yeah. So another quick notice again, as I said, that academy only started producing videos actively last year, okay? And already we have about 20,000 students who have watched us, yet you have still under 1,000 subscribers. If you are finding value here, then please kindly subscribe and help us amplify this work. So this is the eighth question. As I said, pause and solve. If not, let's go through. So I have y prime is equal to e to the power negative y multiplying 2x minus 4. Whenever you have y prime, that is prime, instead of the y over something, you look up for your independent variable, then you see that, oh yes, it's x, so you can change this to the y over the x. Okay, so it's not like you can choose anything. No, we always do with respect to our independent variable. So the y over the x is equal to e to the power negative y multiplying the expression 2x minus 4. How do I solve this? What type of differential equation is this actually? That's the question asked yourself. Now you can see that there is no addition separating the different terms of the equation. Whenever you see certain, then it means your equation is likely to be separable. I use the word likely because it may not be for every situation, but it's likely to be separable. Separable works for most equations which deals with division and what? Multiplication. You can just swap and interchange grouping x and y separately, okay? So here you can see that your x is in one bracket, your y is also separated. What do? I need to get them separated. I'll put y from where it is to this side, and I'll put x to this side. So how do I separate? Let me rewrite it for the y over the x is simply equal to 1 over e to the power what? I'll change the negative and that becomes what? Y. Because this is the same as 1 over e to the power y. Multiplying 2x minus 4 like this. At this point, what do? I cross multiply. So I have e to the power y dy is equal to the x multiplying 2x minus 4, right? Once you have this, you can clearly see that I have separated. I have x on the right, I have y on the left. So what do? I need to integrate, okay? So I need to integrate on both sides. So integral of e to the power y dy should be equal to integral of 2x minus 4 dx. We are going to do it sideways. On the right hand, if you have the integral of e to the power y dy, what's the answer? I think for you to understand differential equation well, please revise integration. Differential equation is just you reversing a differential, and that is exactly integration. So the whole concept of differential equation is just an integration approach, but each type of equation has its own way of integrating or applying the integration. At this point, it's integration, not differential equation. So an integral of e to the power y is always e to the power y, okay? So on my right side, I'm going to have e to the power y, right? Then plus c, is equal to, on the right side, when I integrate this with respect to x, I have 2x. The x becomes what? 1 plus 1, 2, and I divide through by 2, so that gives me x squared. Then my negative 4 becomes minus 4x. That's simple integration, okay, plus c. Please, whenever you do separable, your constant, merge them and get only one. You don't need two constants, okay? And don't think that you can send c to cancel c. No, c is an unknown. It doesn't have a value, so you cannot actually cancel it. So you have this here. You have e to the power y is equal to x squared minus 4x plus c. At this point, remember in the question, I gave, this is what you call initial value problem. I've given you y of 5 to be equal to 0. This is a condition, and the condition is helping us to get rid of our indefinite nature of the constant of integration. So the condition is saying that whenever x is 5, y becomes what? 0. So we go back to our answer. So meaning that when I put x to be 5, y should be what? 0. So I simply have e to the power 0 is equal to 5 squared minus 4 times 5 plus c. Okay, so e to the power 0 is what? 1 is equal to 25 minus 20 plus c. Therefore c will be equal to what? 5, right? So this is 25. So I'm having 25 minus 20 is equal to c. So that is 5, but it's going to be negative. No, sorry, I have one here. So let me do it one here. So doing this gives me 1 is equal to 5 plus c, right? So what my c? My c simply becomes negative 4, which you can clearly see. Once I get negative 4, I'll come back to my equation and change it. So now my answer becomes e to the power y is equal to x squared minus 4x minus 4. Okay, so this is what I have now. So the next thing to do is I need to make y the subject. I've been asked to find y. How do I find y from this expression? You can find y simply by removing this e. How do I get rid of the e? The inverse of e is natural log, okay? So I'll take natural log on both sides. Natural log of e to the power y is equal to natural log of what? X squared minus 4x minus 4. At this point, natural log of e gives me y, okay? It gives you y. Length of the expression x squared minus 4x minus 4, okay? And that is your answer for this problem. That's your answer for this problem, okay? Yeah. So this is how we solve a separable differential equation, and as we've gone through, let's see the next question that we have. Again, I said if you find value here, please do what? Subscribe to support this work. The expression 2x, the expression 2y plus x squared plus 1 dy over dx is equal to 0, with a condition that y of 0 is equal to negative 3. With this differential equation given, how do I know the type? Now you can see clearly that this differential equation is in two parts, separated by everything equals 0. Whenever you see this form, it's then giving an idea of exact differential equation. One difficulty about differential equation is that for you to identify which method to solve a particular differential equation may be a problem. Sometimes a differential equation can be solved by more than one approach, okay? And each approach will have different time that will require for you to solve. If something is separable and you're going to use linear, you may be in trouble, okay? And to avoid that, you make sure that you always make sure that you don't choose the inefficient method, otherwise you'll be in trouble. While somebody has gotten the answer, you are still solving and finding something. Generally, another differential equation is in the form mx plus my. So let me say let me come. Okay, so it has two forms. We have m of a function. It's a function here, the x plus n xy dy is equal to 0, or mostly we have this separated here like this. So we have something like mxy plus ny dy over the x equals 0. When you see anything like this, it's exact differential equation. But interestingly, exact differential equation has a way of testing whether it's exact or not, okay? Because it has two different functions, the m function and the n function, where the n function is always attached to the dy over the x, okay? So I'll have 2xy minus 9x squared, okay? And that is what? My m. Then, so we call it mx because the x function. Then I'll have 2y plus x squared plus 1 to be equal to my ny. That's my n function. At this point, the test for exactness, okay? We do a cross differentiation. Since my m is a function of x, assumedly, okay, we always differentiate your first one with respect to y. So always find mxy. Differentiate your first one, this one, the one which is not attached to the dy over the x. We always differentiate that with respect to y. Then the ny, the one attached to your differential, is always differentiated with respect to x, like opposite, okay? So here I'll find nyx. What's the answer? If I'm differentiating this expression with respect to y, this becomes 0 because any x becomes a constant. So negative 9x squared becomes 0. And here, with respect to y, I'll get 2x because, let me write here, 2x. When I differentiate y, I'll get 1 and it will be left with 2x. Now let's come to the second one. I'm differentiating this with respect to x. With respect to x, anything which is not x is a constant and it will be 0. So far as it's not attached to x. 1 is a constant, is 0. Then 2y here is going to be a constant because it doesn't have any x in it. Now you are left with x squared. So x squared, if I differentiate, I'll get what? 2x. Since these two are equal, then I'll say that my equation is said to be what? Exact. Okay. Now I can confirm that my equation is an exact differential equation. Okay. Once I'm certain that it's exact, what do? I just move straight to solving it. Now let's solve this. To solve an exact differential equation, there's two approaches. Sorry, my English. So the first approach is a very short method. We are going to integrate each of these, the m and the n, separately. Then we do some nice merging here. So let's integrate the first one. Integral of 2xy minus 9x squared. Okay. Whenever you want to do the actual integration, please, we don't do the cross one. Here we find or we integrate with respect to x, because I said this m is always a function of x. This is a function of y. So the x. And what are you getting? You are going to have, you are integrating this with respect to x. Anything y is a constant, you push it out. Okay. So I'll have integral. So my y will go out. So 2y is out. And I have x minus my integral 9x squared. Okay. Each dx. This is by the fundamental theory. If you have any differential integral, you can separate them. Okay. So here you can see that this becomes x squared over 2. And that 2 cancels. So I have y squared. As simple as that. Minus here. When I add 1, it becomes 3. It becomes 3s cubed. I'm done. Now let's come to the other one. Integral 2y plus s squared plus 1. I have to integrate this with respect to y because it's ny. The y part. Integrating this with respect to y, my first one becomes y squared. You can clearly see, right? I'll get my y squared plus this one becomes s cubed. S cubed over 3, right? Then plus what? X. Am I right? Okay. So let's see. Am I on the right path? Okay. So what I did here is we are integrating this with respect to y. Sorry, this is the mistake I've seen. Yeah. So I made a mistake here. But it doesn't look normal to me. Yeah, nicely. So if I want to integrate this with respect to y, my first one is a y. So meaning that when I integrate, it becomes what? Y squared, right? The second one is a x. When you integrate x with respect to y, the x squared becomes s squared. It doesn't change, but there is an appearance of the y. Okay, so we assume that there is a y attached to the x, but the power is 0. If you want to integrate it, you add 1 to the 0, it becomes 1 all over 1. So this y, then plus x. Now you've seen that there are two different integrals here. One, then number what? 2. Okay. The next thing you do is what we call merging. You are going to merge these two. In merging, whenever any two things appear here in common, you take one of them. The uncommon ones, you add everything. Therefore, look at the solution for a differential equation. Our exact differential equation x of y is simply equal to, now y x squared is here, it's also here, you choose 1, y x squared. So 1 here, 1 here. Then the next one is y squared. It's only 1. We have minus 3x cubed is only 1. Then you have plus x, and that becomes our answer to our differential equation. So this is the easiest way you can go by the exact differential equation. Okay. Now let's see something here. I wanted to take you through the other method. Okay, this is a shortcut. Interestingly, the time is going bad. Yes, let me take you through. So to do the second part, let me maintain the answer and clean this side like this, and let's compare. So let's see the actual method of solving exact differential equation. So as I said, this is your m and this is your what? N, right? So straight away what you do is you choose one of them, just choose one. So let's choose m. So m is what? 2xy. So I have integral 2xy minus 9x squared dx. You only choose one. But here, whenever you are doing exact differential equation, it's out of implicit equation, meaning that this exact equation, when you solve this, the constant of proportionality doesn't become c, but becomes a function of y. Let me come again. I said that the exact equation here has two parts. It has the m part, which is the x part, n part, which is the y part, where n is always attached to the y over the x. If you want to solve this by the normal approaches we are going through, here what you do is you take one of them, but when you integrate, your constant of proportionality doesn't become c, but becomes a function of the other which you didn't use. Since you are using m, when you solve, our constant of proportionality is going to be a function of y. So let's see, we solved already. So here, if I'm integrating this with respect to x, I'll simply get what? My y(s) squared, then this becomes minus 3s what cubed plus h of y. Can you clearly see that? So once you do this, this becomes the answer for our entire differential equation. So our exact differential equation becomes yx of y is equal to y(s) squared minus 3s cubed plus h of y. But we are not done. We need to get this h of y done before we can proceed. How do we get this done? You remember that in our differential equation, remember that when you have our general normal equation and I differentiate, I'll get the differential equation. And if I have a differential equation and I integrate, I'll get this back. But since I've gotten my normal but it's not complete, why don't I differentiate and see if I'll get this? Okay, if I don't get, then I'll equate what is missing. So the next thing you do is you differentiate this expression here. Okay, let's differentiate this with respect to what? Y. So the idea is that if this is my total function, then if I differentiate this with respect to y, then I should get this. I don't know if you get it. This whole equation was as a result of me trying to differentiate this, and we got this. Now that we've gotten this, though we don't have the y, but if I differentiate this y, it should be equal to my y here. So let's see. Let's differentiate this with respect to y. I'll simply get what? Here with respect to y, I'll get s squared for the first expression. This to the y will be 0. This expression to y, it should be 0. Then this one becomes h prime of y plus h prime of y. Okay. Now, once I get this, this is my integral with respect to, this is my differential with respect to y, then it means that this expression I have here is equal to my n, because the y part, then you simply equate it to 2y plus x squared plus 1. At this point, we need h prime of y. So what do? H prime of y should be equal to, I'll send my x there. X will cancel x, so I have 2y plus 1. I need y, I don't need h prime. So integral. So I'll have my y to be equal to integral 2y plus 1 dy. Therefore, the answer is what? This becomes what? Y squared plus what? X. So since I found my h, of y, this expression. So this h of y, okay. What do? I simply come back to my main equation and put it there. So now my y of x then becomes ys squared minus 3s cubed. Instead of h of y, you replace it with what? Plus y squared plus x. And that is exactly what we have here as here. So these are the two methods. This is the shortest method and this is the longest method. And that is all for question number 9. Okay, question number 9. Question number 10 instead. Question number 10. So question 10, I have y prime plus 4 over xy is equal to s cubed multiplying y squared. How do we solve this differential equation? Please, before we continue, as I keep on saying, if you find value, don't forget to subscribe to GAT Academy for us to continue providing you value. Yeah. So y prime plus 4 over xy is equal to s cubed y squared. How do I solve this differential equation? I need to know the type of differential equation. The presence of this y squared should tell you that this is not a linear differential equation. Okay, so for us to solve, this falls under what we call Bernoulli differential equation. In Bernoulli, you have a function of y which has a power more than 1 on the. Okay, so here our goal is to remove this y squared to make it linear. That is all. What do? We divide through by y squared, right? So I have y to the power negative 2 y prime plus 4 over x. Y divided by y squared will be y to the power negative 1 is equal to s cubed. This is the first step. Divide through by y squared. After you divide through by y squared, now you can see I have an expression where I have y to the power negative 2 here, I have y here, or y1. So here we use what we call a substitution, a method of substitution. Okay, with our method of substitution, we are going to replace y to the power negative 1 with a letter. So let's say v is equal to y to the power negative 1. Okay, once you have this, you differentiate v. V prime is equal to, now let me explain it well. So as I said, whenever they give you a Bernoulli differential equation, which is an equation which looks like a linear differential equation, but you have an external term which is y squared, you have y to a higher power. The goal of solving a Bernoulli differential equation is to convert it to linear differential equation. Then you solve. After dividing through by y, you realize that you are almost getting a linear differential equation, but there are still terms that is making it non-linear. That is what you want to remove. The first term is y to the power negative 1. You have to change it and make it v, because you are not supposed to get a power of negative 1. Then once you have v, you realize that there is y to the power negative 2. You have to replace that. But if you choose another variable, we can't solve. So you have to differentiate what you have here so that it will become y to the power negative 2. So when I differentiate this, I get negative y to the power negative 2 y prime. Please, whenever you are differentiating with respect to y, you add your y prime. Okay, so here you can make a nice substitution. Okay, in my equation, you realize that I have y to the power negative 2 multiplying y prime. Okay, then I have negative y to the power negative 2. I also have what? Y prime. I can make it the subjects. Okay, so here I'll simply say y to the power negative 2 y1 is equal to negative v prime. Okay, then when I come here, I'll simply replace this with my negative v prime. So this expression becomes negative v prime plus 4 over x My y prime is what? V is equal to x cubed. So at this point, you can see that we have gotten rid of our y, and our equation is now linear. We are not done, but we can divide. For any linear differential equation, please make your derivative stand alone. So I have v prime minus 4 over x v is equal to negative x cubed, like this, nicely. So at this point, what am I going to do? It becomes a linear differential equation. I simply find my integrating factor IE, which is e to the power integral of what? My p of x, and that is negative 4 over x here, dx. So here I get e to the power, my negative 4 comes out, I have 1 over x, right, dx. So which is also equal to e to the power negative 4 ln x. Then the negative 4 becomes the power, right? So we simply have e to the power ln x to the power negative 4. And as I said, e to the power ln, we get the answer to be the number here. So our IE is simply equal to x to the power negative 4. Then at this point, you multiply through by your integrating factor. So I'll simply multiply through. I'll have my v prime times my x to the power negative 4 minus 4 over xv multiplying x to the power negative 4 is equal to negative x cubed times x to the power negative 4. And I said that whenever you are doing linear differential equation and you reach this part, the next thing is you collapse this whole thing and you write v times your integrating factor x to the power negative 4 all prime should be equal to what is on your right hand side. At this point, what do? You add the powers. You add. You'll have negative x to the power negative 1, if you clearly see, right? Then at this point, I need v. I have to integrate both sides. So integrating v x to the power negative 4 prime is equal to integral negative x to the power negative 1 dx. This will cancel this, right? I'll have v times x to the power negative 4 is equal to, when I differentiate this, you get negative ln x. Please take note, plus c. So at this point, this is the same as what? I'll have to get rid of this by multiplying through. So I'm going to get v to be equal to x to the power 4 times negative ln what? X plus c multiplying what? X to the power 4, like this. Okay? So at this point, I have v successfully successfully outside. So this is my value of v. Please, the question didn't give us v, it gave us y. So we go back and remember that the relationship between v and y is that v is equal to y to the power negative 1. So I'll replace my v with y to the power negative 1. Simply, is equal to x to the power 4 multiplying negative ln x plus c multiplying what? X to the power 4. Right? So like this. So here, since we need y, you just take the inverse. So 1 over y is equal to this. Therefore, my y is simply equal to 1 over the expression x4 multiplying ln negative ln x plus c x to the power 4. As simple as that, our differential equation is solved. This is the 10th question. Now, I have this interesting question here, but I would like you to, okay, let's solve one word problem, then I give you a question for you to go and try and see another time, right? So our 11th question, that's going to be something like a word problem. Okay, so I have here the fish population in a lake is attacked by a disease at time t equals 0, with the results that the size p of t of the population at time t greater than or equal to 0 satisfies the equation dp over dt is equal to negative k square root of p. Now, what are the question? You say here where k is a positive constant. Okay, then the question says that if there were initially 90,000 fish in the lake and 40,000 were left after 6 weeks, when will the fish population be reduced to 10,000? Yeah, so this is it. It says the fish population in a lake is attacked by a disease at a time t equals 0, right? With the result that the size of the population at a time t satisfies this equation, where k is a positive constant. If there were initially 90,000 fish in the lake and 40,000 were left after 6 weeks, when will the fish population be reduced to 90,000? This is a beautiful question, right? So how do we solve this? This is an application of differential equation. So let's go straight to solving this problem. We first take our equation dp over dt is equal to negative k multiplying square root of p, right? What type of differential equation is it? It was made mention that it's a positive constant because, if a disease attacks a fish in a population, then it means that the quantity or the population of fish will decrease over time. Some will be dying. So the negative sign here is trying to compensate for the fact that our population will be reducing. So if k becomes negative, then it means that it will make it positive and it will destroy the condition. That is why k should be positive, but the negative sign is showing that the fish will be dying over time. They started with 90,000 fish, and now they are saying that after the 6 weeks, we are left with 40,000, meaning 50,000 died. So when will the fish population then becomes 10,000? This is simple English, but you need to solve it, right? So to solve this, for us to solve this expression, how many ways can you solve this? This is where you ask yourself, is this linear? Is this separable? Whatever. So we can say that this is linear, right? We can also say that this is separable. So dp over dt plus k square root of p is equal to 0. That is one way. This is a perfect linear equation. Another way to come here. When I have here, I'll have dp over square root of p, right, is equal to negative k dt. And this one is a perfect separable. Which one are we going for? Which one are we going for? Let's try. So let's start with the separable. Starting with the separable, I'll have my integral, right? You just integrate both sides. So I'll have my integral dp, no, integral 1 over square root of p. So let me make it p to the power negative half. If you have 1 over square root of p is p to the power negative half, dp is equal to integral negative k dt. If you integrate this one, you are adding 1 to negative half. That will give us what? Half. So p to the power half divided by half, right? Plus c is equal to, here I'll simply introduce kt, as simple as that, plus c. So here, my p to the power half, it becomes 2 root p plus c is equal to negative kt plus c. So I'll simply say that my answer is what? 2 root p is plus k is equal to c, as simple as that. So this is what we have gotten. Now let's try using the linear and see if we get the same answer. So with the linear, we are going to have and we have to find the integrating factor, right? I.e. should be equal to e to the power integral of what is here. Now you realize something here, that this can't be linear. Why can't this be linear? Because p here is to the power a radical half. Linear says your p should be to the power 1. So meaning this is not accepted, please. We can't use linear. So let's go by this. Since we have this, what's the condition saying? You say initially there were 90,000 fish in the population. So meaning that beautifully at t is equal to 0, we have the p to be equal to what? 90,000. This can help us find our constant, is that not it? So let's find our constant. So here I'll have 2 multiplying square root of p, 90,000, right, plus my k is equal to c is what? cc, right? So our time, sorry, kt, I left c, so my kt and the time is 0 is equal to c. So now this becomes 0, so I'll have 2 roots. Remember that if you have 90,000, the square root will cancel 2 zeros, right? So 2 zeros should already come out. Then also the 9 itself will be 3, so we end up getting 300, right? So 2 times 300 is 600 plus this 0 is equal to c. Therefore c is equal to what? 600, right? So at this point you see that our equation is 2 root p plus kt is equal to 600. Another condition came again, saying that when the population of the fish became 40,000 after 6 weeks. So meaning that we say that time equals 6 weeks, p is equal to 40,000. We can use that to find our k. So 2 root 40,000 plus my k, which I don't know, but the time is 6, is equal to 600, right? At this point, what am I getting? This gives 200, right? 200 times 2 is 400. 400 plus 6k is equal to 600. Therefore, I'll do my subtraction. I'll get 6k to be equal to 200. Then k is simply equal to 200 over 6. 2 goes here 100, 2 goes here 3. So k is 100 over 3. But the question is, at what time will the fish population be reduced to 10,000? Meaning that we are now looking for t, and we are saying p is equal to 10,000. But we know our k, right? So let me rewrite the equation. My equation is now 2 root p plus my k, which is 100 over 3 t, is equal to 600. Now I want to find the value of t when p is 10,000. I simply put 10,000 here. So 2 root 10,000 plus 100 over 3t is equal to 600. But the c is what I'm looking for. 10,000, square root of 10,000 is 100, okay? So I get 100 times 2, 200. So 200 plus 100 over 3 times t is equal to 600. 200 subtracts, and I get 100 over 3t is equal to 400. 100t is equal to 1200. 2 zeros cancel 2 zeros. T is equal to what? 12 weeks. So our answer is 12 weeks. And this is a very simple application of a differential equation. At this point, I'm going to give you a problem to go and solve for me. So I'll meet you another time on this, then I'll see your solution. So go and solve this differential equation for me. So that is going to be 3y cubed e to the power 3xy minus 1 plus multiplying 2y e to the power 3xy plus 3xy squared e to the power 3xy close bracket y prime equals 0. Yeah, so this is what we have here. Thank you for being with us, and please, we haven't reached the 1,000 goal yet. If you find value here, please subscribe to support. Thank you. See you another time.